I'd first like to direct your attention to the left-hand part of the screen, where I've drawn some examples of isoquants. Standard production function uses water and fertilizer to produce corn. I've got the 20 bushel isoquant, 40 bushel isoquant, and 50 bushel isoquant drawn. First, I'd like you to think about how this appears in 3 dimensions. In 3 dimensions, the corn axis, Q, would be going out of the screen. And so if you can think of taking the 20 bushel isoquant line and popping it out of the screen 20 units, then taking the 40 bushel isoquant and popping it out 40 units, and then taking the 50 bushel isoquant and popping it out 50 units, you get a 3-dimensional picture of what this is like. It looks kind of like going up, kind of like a mountain, and the slopes of a mountain. There are other ways of depicting this 3-dimensional object, and that's the purpose of this lesson and the purpose of the graphs that I'm going to draw on the right. First, think about being at approximately, say, this position. So think about this as being a mountain, and it's surrounded by a plain, and you're in this position in the plain, and you're looking at the mountain this way. And I want to take a cross section of the mountain. You could think about a bulldozer scraping off this part of the mountain. In other words, going in this direction and scraping off everything that's above the plane, the WF plane. And think about what the cut surface of the mountain then would appear like if you're gazing from left to right at the surface from this position down here. So that would be holding fertilizer fixed at 2 pounds, and going from left to right, that is varying water, and then seeing how corn output changes. So let me repeat. That's holding fertilizer fixed at 2, changing water, and as you change water from left to right, you go up and down and you see how Q changes. I'm going to draw that in the upper right-hand graph, because the horizontal axis is going to be water holding fertilizer fixed, which I'm going to note with a straight line and then a small f subscript. So a straight line and then a small subscript means that whatever is denoted by the small subscript is held fixed. I'm going to keep fertilizer fixed. So from left to right, I change water, and then up and down, I'm looking at how Q changes. So when water is fixed at 2 gallons, when fertilizer is fixed at 2 pounds, that's here, fertilizer is fixed at 2 pounds, I have one observation, which is this observation here, which is that when water is 5 gallons, you can produce 20 bushels of corn. So when water is 5 gallons, which in the upper right graph is here, when water is 5 gallons, I can produce 20 bushels of corn. When fertilizer is fixed at 2 pounds. Now, how about moving to fertilizer being fixed at 7 pounds? So you can imagine the bulldozer coming back, and now removing everything that's above the plane that's above the WF plane below an F level of 7, and then looking at the cut surface. And now we have 2 observation points. Okay, so when fertilizer is fixed at 7 pounds, first observation point says if water is 3 gallons, you can produce 20 bushels. Right, that's this point here. 3 gallons and 20 bushels. So 3 gallons of water is here, and that produces 20 bushels of corn. And that's what, and then at W equals 5 gallons, we're at this point, and we can produce 40 bushels of corn. So at W equals 5 gallons, we can produce 40 bushels of corn. Okay. And that's, again, what happens when F is fixed at 7. So that's what happens when F is fixed at 7 pounds. Now let's bring the bulldozer back and have the bulldozer delete everything below 15 pounds. So now we have another cross section. This cross section has 3 observation points. The first observation point is where W equals 2, and at F equals 15 and W equals 2, that's this point, you can produce 20 bushels. So on the upper right hand graph, when W equals 2, you can produce 20 bushels. When on the left hand graph, when W equals 3, you can produce 40 bushels at an F equals 15, so 3 and 40. And finally, we get this point here, which is at F equals 15 and W equals 5, you can produce 50 bushels of corn. So 5 and 50 bushels of corn. So that looks as follows. So what happens when F is constantly equal to 15 pounds. And this is the one that probably looks most like the cross-section of a mountain. These are called total product of water curves. Total product of water curves are drawn holding fertilizer fixed. There's not just one total product of water curves. There are an infinite number of total product of water curves depending on what level fertilizer is fixed at. Here I've drawn 3 of them. One where fertilizer is fixed at 2, one where fertilizer is fixed at 7, one where fertilizer is fixed at 15. So I'll say total product of water curves using the plural because these are 3 examples. So this is another way of depicting the 3-dimensional object where I'm in the position of observer at the bottom and having water change from left to right. Now, I can do this another way if I assume that my observer is here. Mark that with another color. Here. Looking down and then looking to the right and then to the left, having fertilizer changed as the observer changes his gaze from right to left. Looking up and down, Q is going to change. So let's see how that works. So again, the left-right motion is going to be F, the up-down motion is going to be Q, so that corresponds to the bottom right-hand graph where you have F on one axis and Q on the other axis. So first we'll do what happens when W is fixed at 2. So when W is fixed at 2, then we only have one observation, which is this observation, which is 15 pounds of fertilizer gives rise to 20 bushels of corn. Okay. So 15 pounds of fertilizer gives rise to 20 bushels of corn. That's here. 15 pounds of fertilizer, 20 bushels of corn. And that's what happens when W equals 2 gallons. Next, what happens when we keep W fixed at 3? We have two observations, this one and this one. The first observation says that at 7 gallons of fertilizer, you can produce 20 bushels of corn. At 7 gallons of fertilizer, you can produce 20 bushels of corn. And the second one says that at 15 pounds of fertilizer, you can produce 40 bushels of corn. So 15 pounds of fertilizer, 40 bushels of corn. So that's this relationship. And that's what happens when water is fixed at 3 gallons. Finally, what happens when water is fixed at 5 gallons? Well, then we have 3 observation points. The first observation point, which is this one, which is that 2 pounds of fertilizer produce 20 bushels of corn. 2 pounds of fertilizer produce 20 bushels of corn. The next observation point is this one. Oops, I'll make it a different color. This one here, which says that 7 pounds of fertilizer produce 40 bushels of corn. So 7 pounds produce 40 bushels of corn. And finally, we've got this point, which says that 15 pounds of fertilizer produce 50 bushels of corn. So 15 pounds of fertilizer produce 50 bushels of corn. So let me draw lines connecting those points. So that's what happens when W is fixed at 5 gallons. So this is another perspective on this three-dimensional object. The horizontal axis here is fertilizer with water held fixed, and that's the way you depict that, with a vertical line and a W subscript. These are called total product of fertilizer curves. And it's particularly of note that if you look at the highest curve on both of these graphs, on the one on the upper right, it's the f equals 15, and the one on the lower right, it's the w equals 5. You see that they're concave. We'll see how to interpret that in the next lesson. That's actually a fairly important interpretation. It's actually the reason why I drew these graphs carefully with numbers in order to get those to be concave, because the concave shape of total product curves is pretty important. For now, you can think of these as just being other geometrical ways of illustrating the three-dimensional diagram, which, as I said before, looks kind of like a hill or a mountain, illustrating that in just 2 dimensions. But we're going to see in the next lesson that there are, and further along, that there are important economic interpretations of total product curves.